let's talk about 10 things and let's talk about what it is that we've built. It's robot infrastructure for the next decade. And what that means is we have stood up a platform that allows you to go from an idea CAD model all the way through your deployment cycle and your robot in production, ensuring that over time we understand how the robot's performing at the individual level of each robot. Where it's been, what kind of missions it's done, whether it's successful or not, all those things are part of this platform. So when most robotic companies start out, they have an idea, they've built something, or they're thinking about building something and they have work done in CAD models and they're trying to move it to the simulator. So that is the core infrastructure of our platform, is getting you to from that CAD model all the way through into the simulator, from the simulator to control code, from the control code to fine-grained policy development. If your robot has hands or it has feet and it needs to walk, we will measure all the potential models out there, whole body controllers, policies, etc. We'll bring all of those to your robot in a way that you can just compare how does one model work against another. If you're using Groot or you're using Pi 0.5 and soon to be Pi 0.6, you can just say, how does this work for my robot? So, and we know that, robotic teams you're so focused on building a robot that sometimes at the point in which you're designing and building, it just becomes overwhelming. I spent the last 30 years working with various companies and the last 20 years in robotics and leading teams in robotics. So I put together a comprehensive guide in the form of software that you can use on your own to work out a lot of these pain points. And some of them I have listed here. These are more solutions to pain points. So this is fleet ready from day one. And what does that mean? Is all of your deployment cycle, all of your telemetry, all built into one of 6 hubs that we've built. And so these, I'm not going to deep dive into all of them right now because there's so many things going on, but we've built out several hubs that allow you to, and you can see them here along the side, that allow you to go from, I have CAD model all the way through deployment and then past deployment into governance of your robot. And these tend to be things that if you're building out a robotic company that you don't have time to deal with on day one. Here we're trying to get the robot to walk. And so we're not thinking about what happens in deployment. And it happens to come upon us very quickly. If we look at some of the companies that have just announced their robots in days, they were funded and people are expecting outcomes from them. And we know that all the talent is not available to all these companies. So what I'm trying to do is build out a platform in which we get in all the feedback from various companies into one place. We built out a team that allows us to take on any problem that robotics companies face in mass and bring them into a platform. So I'm going to just go over just a little bit about that. We have these platforms and they all have a shared SDK. So there's the pattern that we're using is one in which that they're primitives, very, very discrete functions that are built, and layered on top of them are various capabilities in the form of tooling that you can use in the CLI or MCP. So today we're going to take a look at one of those tools, and we call it BYOI, and that's bring your own instance. And what bring your own instance really means is that you can basically bring the environment that you're already using into the system and leave it local on your machine and run that against tools that we've created. So another thing I hear from robotic engineers is that we don't want to expose our IP out to the world. We don't want everybody just having it. And similarly, nobody wants that. So I don't want that for you. So what we allow you to do is keep that on your system and use the tools in the form of an MCP server out in the cloud. And now we're talking to each other, and you keep your data, you keep everything, your code, all in your own container. And then you can call tools, and I'm going to explain that in a second how that works. Right now we have 56 MCP tools. Every day this number goes up by at least one. We should. I have a plan to have at least 300 or 400 in the next month or two that are actually 100% useful. A lot of people say they have tooling, and it really is not that useful. But here we are showing you everything that we've built. We're showing you in real time the things that we're building and continuously improving. One of the main tasks that we are looking at is how to make it so that engineers can do very, very discrete tasks in a timely fashion over time. And when you think about that, one of the things that comes to mind is I use a lot of NVIDIA products and Jetson products, Jetson Thor, Jetson AGX Orin, Jetson Nano, Jetson Nano Super, the old Nano, the T1, if you remember that, and T2. I've used them all. And my common interest in helping other developers is I want to move this platform out quicker. I want robotics to scale and be ubiquitous. I want them to be in every home. I want them to serve all kinds of purposes. I want your teenagers to be able to design and build robots in their future just by going to a platform and maybe not knowing every part of it, but understanding how the platform in its entirety works. So here is just a little bit of information about some of the things you can do. These are just some of the test cases that I've ensured that you can do in the latest newsletter. And so you can use, common code editors like VS Code, Cursor, those kinds of things if you're into using a code editor. And it exposes a bunch of MCP tools and then dev containers. So the way this works is you bring your image that you want to use, or you say to it, you naturally write in natural language, I want to stand up an image of Ubuntu 2404, and it needs to have these components. It needs to be capable of ROS2, Humble, Jazzy, whatever it is that you're using. It needs to have PyTorch, OpenCV. You can type that in natural language, and it'll just stand that container up for you. Or if you already have one, and great, you have a robot already, you can bring your robot back into a containerized environment. What this gives you is the ability to version. So I have a container, I'm going to have my source container, and as I make changes, I'm going to spawn a new container that just says, this is exactly the container before version 1.1, let's say, and now we're going to do our work in that container. When we decide that everything is great, we move on and call that the new container, and we can push that back to the robot, or we can roll back that container if we think that something doesn't look like something's not working in our audits or our code testing pipeline, those kinds of things. I'm not going to kind of boil the ocean with all this and kind of talk about everything that's sitting here, but one of the really interesting things is that you can analyze the code that you have. I can look for security gaps. I can look for performance improvements. I can even say that this container doesn't contain the things that I need. Tell me what I need from my container. Like, for instance, I can say something like, I have a robot and it's got cameras, and the cameras are, say, RealSense, Luxonis, or whatever they might be, Stereolabs, Zeds, or whatever they are. I want to be able to say that this camera, sorry about that, sorry guys, that this camera exists, and I want you to go find the code for that, or the functionality exists, go find the code. And so if we have knowledge of your CAD model or your bill of materials, someplace where we can get the parts that exist, we can go find the code that it takes to run that thing from the manufacturer, and if not from the manufacturer, we can create the code ourselves using our code generation tool. So we've talked a lot. Let me show slightest demo, and I've already got it here and running and ready for us. So let's, I don't need to move much out of the way, I'll just let this go. So first thing we do is we're going to run an MCP server. This one is running locally on purpose, showing that we can run this entirety of the platform on your local devices if they meet the standard. We can also run in the cloud. We can also run in a cloud multi-tenant situation and save everyone a bunch of money. So I've done some things already. So I was testing some robots. So I created all these robots, and some of these are not useful. So I used my MCP tool right inside of Copilot to use whatever model that I want to use against my MCP tooling. So here I've got a bunch of tools. Right now I said there's 56 of them. There's actually more, and so now I can do like say in natural language, how many containers do I have? And we're going to go back, if you know anything about MCP, it's going to check, oh, I have a tool for that. And it's going to go back and take a look at, it's saying like MCP servers do exist for this. And so now I'm going to take a look at and saying, okay, I have a tool, great. And so now I'm going to look at the Docker containers. And we're not going to actually do that, but we can say we can do that. The other thing I can do is generate code from a prompt. Well, you can already do that in here, but the case for code generation is that we're going back to a model that is purpose built to extend the models that already exist and generate code for us in our known environment. So think about it like this. I have my container. I have already the things that work inside my container. I know I'm using OpenCV. I know I'm using NVIDIA Isaac Ross 4.1, etc. So I know all these things. Now my code generation is going to be prompted by this generation prompt, and we'll go back and get the code from my container. I can't tell you how instrumental this has been in my own development experience, because now when, let's say I'm writing code and I know that I need a certain thing, I don't have to worry about my code generator eating a bunch of tokens and saying, oh, I see this. No, I see that. Okay, this also happened. Now I know that it's looking at my container. It knows exactly what's capable in my container. It can add to that, or it can say, I already know that this already exists. So let's just use it. Let's get a project. Let's say what projects do I have? Period. We'll just let that go. And then you can see there are many tools, and they're all over, in different areas of our capabilities. So we won't go into every tool, but the idea is that now it's saying, okay, I need to check list projects. And in this particular instance, I have one project, and that's intentional because we don't want you to see all of the work that we're doing. But this is a project. It's called Amber. It's going to be our demo project that everyone will be able to download and build and use themselves. And it has 2 arms and 12 joints and hands and the head, and it's mobile, etc. It's got a ball screw in it, and I'll show what it looks like in another subsequent video. But you can see this is Amber. It was created on February 4th, last updated February 19th. So I can say, okay, I'm in the Amber now. I have that context, and I can say, what code is missing for Amber, and hopefully it says everything is missing, because we really haven't generated, or maybe Project Amber. We haven't generated any code. This is our demo environment, so it's going to reset right after we're done here. So it'll then say, like, all right, what code is missing for Amber? Let me just look at all the inside the project. Let's get all the artifacts inside the project, and then it will go. And artifacts are, think about it like these are code, these are documentation. This is CAD, this is USDZ files, this is URDF files, and then it will go and tell us about the gaps in Project Amber, which there are many. And I can auto allow all of these. I don't want it to do that. I want you guys to see what it's looking at, what it's doing, and where the clicks are. I want you to get real comfortable with this, because this is really all you'll be doing all day long is talking to the system where we used to really have to write code, and we really, even now with prompts, we have to get real specific about what we want the system to do. And what I've created is a way for you to alleviate all of those problems and get your dev time and your engineering time down to the most important bits of your engineering process. So it is now going off as doing a summary, because we've done quite a bit. It looked at all the code, and it's going to create a summary, and then it's going to come back and say Project Amber is missing all the code. Hopefully that's what we want to have happen, because we have not even launched the pipeline for Project Amber. So the code that's there would be quite minor, if any at all. We do have functionality that builds out the entire coding process based on what it sees in a URDF file, or what it sees in a USD file, or what it sees in the CAD model. We're also doing that. So I'm a little bit stalling because I'm waiting for the summary to come back. This is quite a bit of things that's happening in the background. But when it does come back, we can talk a little bit further about some of the other things that exist in the project. As we look through all of these, you might notice that they're organized by the hub that it's in. So we're building out a bunch of hubs, and the ones here on the right are complete. The ones on the left are things that I think the dev community needs, and I'm working on that. So we can see here, oh my goodness, Project Amber is missing everything. It's stuck in ingestion status since February 19th. 0 artifacts. It needs ROS packages. It needs hardware. Here's the biggest problem. It checked everything. Cosmetically, it's like, oh my gosh, it's all over the place. And in the coming days, since this is quite a long video, we'll go into how we mitigate this for Project Amber just in here with nothing else. Like, we don't need any, and we actually have an even bigger capability that's called Imagine. And it just goes through and looks at all the gaps and says, I'm just going to write all the code for you, and you tell me if it's right or wrong. What I do suggest, and as an engineer I suggest, is any code that's written, that you definitely review that code, understand how it works. We're creating our own models here as well to help you with further understanding and further streamlining and making sure your code is correct. But just know that this is still code, still written by a code assistant. So we want to make sure that we follow best practices there. So we just take a look at this. We'll just minimize everything else. You'll see here it says, here are the gaps. The Project Amber is using this package, and it's using, here's the package called OpenARM description. So at least that's healthy. It's got a ROS2 package that's healthy. There's some parts of Isaac Lab that are not healthy, on and on and on. Isaac Sim is completely unhealthy. And, that goes through the biggest problems. Like, there's not error handling in the project. There's ROS nodes without lifecycle management. We can go on and on and on about the findings. From Isaac Lab, there are some issues there. In the project itself. So it goes through and says, hey, we recommend running the discovery pipeline. Let's figure out what's wrong with Amber, and then we'll populate the empty packages, and then says, you want me to run the pipeline now, or are we going to look at some of these other things? So this is a long enough video, but I wanted to just kind of go back to where we started out and just kind of talk through some of the cases that we cover. And here we are. We're in VS Code. We're running inside of a container. If I make a change, I can roll back my change, including deletions. If we're asking questions based on natural language, we saw code recommendations. And your code is yours. It has not gone anywhere outside of this environment. It does transit through the code gen system and back to your environment. None of that's being stored anywhere but on your machine. So you now are responsible for all those things. And you're developing using here, you saw an MCP, but we also have a UI, and we also have, you can run straight in the CLI if you wanted to do that. So this is the idea, is you're bringing your own container, bringing your own instance, and we're going to get you through from development idea all the way through production. And it's just as one of the many things, one of the many features that 10 Things is offering and bringing to the table. Well, this is a long enough video. I'd like to thank you for your time, and we'll talk to you all soon.